The first thing is to talk about this idea of parametric coordinates. So parametric means pair of measures. So basically we're used to using Cartesian coordinates, where we represent the equation of the curve with one equation, but then we represent the point with two numbers, an x coordinate and a y coordinate. So that's Cartesian coordinates. Parametric coordinates is the other way around, where we represent the point with one number, which we call the parameter, but we describe the curve with two equations, one for the x value, one for the y value. And then we just substitute that one number into each of those to get the two coordinates. So, alright. Our parabola is the most common shape, it's certainly the one we're going to be working with in this parametrics. Hey, we've seen it's x squared equals 4ay when it's written in Cartesian form. Its parametric form is this. To get the x value, it's 2at. To get the y value, it's at squared. And then we just substitute individual. So the origin would be the single number t equals 0. Because when you substitute into the x equation, you get 0. Substitute into the y equation, you also get 0. So for this particular parabola, the origin would be t equals 0. At t equals 1, we would have the coordinates 2a, a, and so on, and so on. So they're our parametric, coordinates, equations, either way. So there's the point 2a, a that I was just talking about. That would be the Cartesian coordinates, which we get from the parameter t equals 1. So over here on the left-hand side, minus 4a, 4a, that would be when the parameter is t equals negative 2. If you substitute it into the x equation, we get minus 4a, and sub it into the y equation, we get positive 4a. So that's the idea of parametrics. Instead of expressing it as one shape, we have a look individually at the x values and the y values to two different equations. So any point in our parabola, x squared equals 4ay, will have coordinates 2at for the x value, at squared for the y value. So that's the standard form we're going to use for the parabola. There are possibly other ways we could write parametric coordinates, but this is the standard one that we use. A still represents the focal length, same as before in x squared equals 4ay. And t is just simply any real number that we can substitute in, and we'll get a point on our parabola. Alright, well let's have a look at this one then. So if we've got the parametrics, x equals half t, y equals a quarter t squared, what's the Cartesian equation? I guess the easiest way of doing that is eliminating the t. It's like having simultaneous equations. I can make t the subject of the first one, sub that into y, and we get our basic y equals x squared for that one. The coordinates of the focus, well, we've now got a couple of ways of doing it. We could look at the final equation and go, oh, well, we know x squared equals 4ay, so 4a is 1. Or we could look at the parametrics ones and say, well, I know x is 2at, so 2a is a half. Or I could look at the y one and go, well, I know the y one is at squared, so a straight away. And that one, I go, a is a quarter. So whichever way we choose to do it, we end up with a being a quarter. So the focus, remember the focus was 0a. So the focus will be 0 a quarter. So we're going to work out the parametric coordinates for y equals 8x squared. Remember, it's x squared equals 4ay. So don't think 4a is 8. 4a would actually be 1/8. So a is 1 on 32. So I could create parametrics where it's 2at, so 2 times 1 on 32 is 1 on 16. So the x coordinate would be 1 on 16t. The y one, at squared, so 1 on 32 t squared. That would be the parametrics. So there's a little one to start off with. You'll notice I've said there, not latus rectum. Latus rectum's not actually in the course anymore. It used to be going back, quite a few years ago. All the latus rectum is the chord that goes through the focus. So it's y equals a. The directrix is y equals minus a, the lattice rectum is y equals positive a. And sometimes they also ask, what's the length of the lattice rectum? Or they used to ask, because, as I say, not in the course anymore. And they mean when it's cut off by the parabola. I think it turns out to be 4a from memory, but it's always 4a. But as I say, we don't need to know that.